Good afternoon, friends. Welcome to our webinar. Welcome from the team at the Regen Academy and from Advancing Eco Agriculture. The Regen Ag Academy is a project that we're working on at Advancing Eco Agriculture to share more of the in-depth knowledge and information of the things that we have learned over the last decade in our crop consulting work. That they're often topics that are really deep, they're very nuanced, and they require some more in-depth explanation and are deeper than we can get into on a podcast or on a webinar. So we're putting together a series of online courses at the Academy. We've already received really strong, favorable feedback from many people who have participated in the first two courses, which have both been posted now, and we hope that you'll join us there. So the topic for this webinar is how to design foliar applications and how to put foliar applications together to get the greatest crop response. And I think this is a very important topic because it's a topic that we've received many questions about. Foliar applications are, I believe, one of the most powerful tools, if not the single most powerful tool, and one of the most effective tools at accelerating regenerative agriculture systems and driving soil health and driving plant health to a much greater degree. And this is an idea that is quite different from what the historical mainstream view has been. The historical view has often been that using foliar applications allows plants to grow larger and stronger and produce higher yields without adding as many nutrients to the soil, and can actually deplete the soil of nutrients over time. And this can be true if it's managed that way. But it can also be true that we can manage foliar applications to dramatically increase plant health and actually have a positive effect on the soil rather than a negative effect, that we can actually regenerate soil health, build soil organic matter, sequester carbon very rapidly while we're growing a crop. So I think this is a very different way of thinking about foliar applications and the benefits and the impact that they can have. There is this idea that it takes healthy soil to grow a healthy crop. And while that is not incorrect, it certainly is incomplete. The reality is that it takes healthy plants to create healthy soil. In fact, it is healthy plants that are the engine that create healthy soil. If it wouldn't be for plants, soil would be nothing more than decomposed rock. But it is actually plants that sequester carbon, transfer carbon out through the roots as root exudates, and produce organic matter, provide a substrate for microbial activity for very rapid microbial digestion. So in effect, it is actually plants that create healthy soil, not the other way around. And the use of foliar applications to increase plants' health can speed up that process very quickly. And at the same time, we also get all these additional benefits of increased disease and insect resistance, increased yields, and overall plant quality and crop quality. So in our webinar today, I want to speak about some very general principles and high-level guidelines of how to put together a foliar application that works. Because what we've observed is many times when growers apply foliar applications of nutrients or biostimulants, and they don't get the effects that their neighboring growers might be getting or that they hear about, it's often because of how the foliar application was designed. So I want to speak about some of the aspects that we've learned of managing and putting together a foliar spray solution, the sequence in which we combine products, the type of water quality that we use, and these various aspects. I saved the most important comment for last. Thank you for being here. We really enjoy working with all of you on your operations, helping you to grow really healthy plants. We have a lot of fun in the work that we do here at Advancing Eco Agriculture and at the Academy. And we really appreciate the feedback that you give us and being able to closely collaborate with you on your operations. So thank you. We have a lot of fun, and we couldn't do it without you. So we really enjoy it. All right. So thinking about using foliar applications as part of a system to regenerate soil health, to regenerate plant health, and how we can design foliar sprays to have the greatest possible impact. Perhaps the first point is that we need to begin thinking about, when you look at this subtitle, using foliar as a system, we don't usually think about foliar applications as a system. Usually we think about foliar applications as a point and shoot solution for a specific problem. We wait until we have a problem with the presence of a disease or an insect, and then we put on an application of nutrients or biostimulants or pesticides or biocontrols to affect that specific problem. Or similarly, perhaps we have a trace mineral deficiency and we wait until we have a trace mineral deficiency showing up, and then we put on an application to address that deficiency. Or perhaps we know that historically we have a deficiency showing up at a certain stage of the plant's development, and then we put on those applications. The point being that usually we don't think of using foliar applications as a standard part of a system to regenerate the entire ecosystem. They're more of a last resort. And I believe we are doing foliar applications a substantial disservice when we think about them in that manner. When we think about the overall soil plant ecosystem and how soils and plants work together to regenerate the entire ecosystem, or to degenerate for that matter, one of the questions that I asked early on was, where are the trigger points in this system? Where are the trigger points where we can introduce a small amount of product and have a completely disproportionate crop response? In effect, where can we hack the system? And I believe that using foliar sprays and foliar applications of nutrients and biostimulants is how we can most effectively and most easily hack the system. Because with using foliar applications, we can harness the plant's photosynthetic engine and put on product applications measured in quantities of grams or ounces or perhaps a few pounds per acre and produce a tremendous crop response. It is one of the well-designed foliar applications are without question one of the most effective ways, most cost-effective ways of producing a strong crop response. And they produce one of the highest ROIs, most consistent, that we can put on a small amount of product and produce a tremendous crop response. And one of the ways of thinking about this is thinking about using foliar applications to increase Brix readings. So the point of this graph is not so much about the Brix reading themselves. I'm just using the Brix readings as an indicator, as an analog for overall plant health and quality. So when we think about using foliar applications, the purpose and the intent is to increase a plant's baseline Brix reading over time. So let's say, for example, that we are working with a crop of pistachios. And when we first begin working with the pistachios, we have a baseline Brix reading of 4. And we put on a foliar application. And when we put on this foliar application, the Brix reading spikes from a 4 all the way up to a 12. We get this very rapid spike. And this spike in a well-designed foliar should happen in a matter of hours. Sometimes it can happen as little as 20 to 30 minutes. Sometimes it can take 2 to 3 hours. If we don't get that Brix response spike within 24 hours of application, then our foliar application has been ineffective at producing this accelerating effect in increasing overall plant health and overall soil health. There should be a strong Brix response spike very quickly. Then that Brix reading will gradually drop back down from a 12, perhaps down to a 4.5 or a 5. And the speed at which it drops down from the peak can vary. In really healthy ecosystems where we have vibrant soil health, vibrant microbial communities, and really vigorous plants, we can sustain a high Brix reading and this elevated spike Brix reading for as much as 4 to 6 weeks. And when we have really unhealthy soils, really challenged soil microbial communities and really unhealthy plants, it can drop from a 12 back down to a 4.5 or a 5 in as little as 3 days. So the healthier the system becomes, the bigger and the more long-term the effect of a foliar application. And not only that, but the healthier the system becomes, the smaller quantities of product that need to be applied as a foliar in order to produce the greatest crop response. You get a much larger crop response with a smaller quantity input, the healthier the ecosystem becomes. So then over time, now the Brix reading is dropped back down to, let's say, a 5. Now we put on a second foliar application, and the Brix reading spikes back up, but this time it spikes up to a 14. And then gradually it drops back down again, and now it drops down to a 6. And we put on a third foliar application, and it spikes back up to a 16. And from the peak of 16, it drops back down perhaps to an 8. I'm just making up hypothetical numbers. But the point is that over time, while There are variations from crop to crop, but all crops have a threshold at which, when the plants are consistently above a given Brix threshold, let's say, I'm not sure exactly what it is for pistachios, but let's make up a hypothetical example to say that it is about 16. Once you have the Brix level above 16 consistently measured anywhere on the plant, then that crop will be largely resistant to diseases and insects. In fact, you can almost say that it will be completely resistant. Now, the interesting part is that plants or diseases and insects and possible potential pests will always attack the weakest part of the plant first. And so the weakest part of the plant for reproductive crops is often the fruit itself. So it's possible, for example, to have a leaf that has a Brix of 16, but the fruit only has a Brix of 4. Or on some crops, such as sweet corn, for example, it's possible to have a sweet corn ear that has a Brix of 22 because it's been bred to have a high sugar content, and the leaf and the stalk still has a Brix of 3 or 4. So you can still have European corn borer and corn earworm feeding on this corn because certain parts of the plant have a low Brix reading. But the point of this entire exercise is that over time, we want to increase the baseline such that once the baseline level Brix readings are high enough, we no longer need to use foliar applications to sustain them. Once we, on this pistachio example, once we get the baseline over a series of foliar applications up to a baseline greater than 16, then we no longer need to use foliar applications to maintain plant health and to maintain disease and insect resistance. And that's when we can have a conversation about a truly regenerative agriculture, a system of soil and plant health that is so vibrant and self-sustaining that we don't need to constantly apply additional inputs. That's the intent. That's what we're trying to accomplish, and that's what can be accomplished using this thought process and this model and properly designing foliar applications. A very important aspect of managing foliars and using foliars as a system is testing the performance. And there are two types of testing that are generally reliable and that can give us a good indicator of what's happening and what's going on. The most valuable in terms of measuring precise nutrients and measuring a plant-specific nutritional integrity is using SAP analysis. You use a SAP analysis before an application, and then again, a few days or a few weeks after application, can be as little as 48 hours to 72 hours. And you'll be able to observe how the plant's nutritional profile changed in response to the product application that you put on. That can tell you very quickly about whether a product is actually performing or not, whether you're getting a strong plant performance response. And the interesting part is often when you have plants and soil ecosystems that are generally healthy, if you put on well-designed foliar applications that increase a plant's photosynthesis response, it is very common to see an increase in nutrient absorption of nutrients that the foliar application did not contain. So, for example, perhaps we have a crop that SAP analysis shows to be low in iron and manganese, and we put on a foliar application that contains iron and manganese. On the following SAP analysis, the iron and the manganese numbers have substantially increased, and perhaps zinc and copper and boron have also substantially increased by as much as 30 to 40%, and yet we didn't apply any. Those are the possible effects of well-designed foliars, because well-designed foliars that trigger this photosynthetic response don't just increase the nutrient levels of nutrients that might be missing. They also produce this strong sugar flush that's down into the root system and feeds biology and the bacterial biomass in the soil profile to mineralize nutrients and make those nutrients available to the plant, where we now see increased availability and absorption of copper and zinc and boron that we didn't actually apply, or at least not in that particular foliar. A second tool to measure the effectiveness of a foliar application, and this can actually be used before we apply a foliar application, is to check the performance of a specific combination by applying it on a small test plot and then testing the Brix level of the treated and the untreated section. So you can easily just mix up a small amount of solution in a spritz bottle, make sure that you calibrate it correctly so that you get the correct application rate, and measure the performance of how the Brix reading has increased within a few hours after application. The goal is to observe a Brix reading spike and see that spikes begin to happen. So if the Brix reading starts moving from a 3, even if it's only at a 6 or an 8, within a few hours, it's likely going to continue spiking for as much as 24 to 48 hours after application. So you can measure the effectiveness of a foliar application before you actually apply the product. And then you can also use this to experiment, to test different foliar combinations and what types of blends that you might want to apply and which the plants respond the most strongly to. And it can be very surprising. The blends or combinations that produce the biggest crop response are not always what we might expect. So when we think about designing a tank mix, there are a number of ingredients that every well-designed foliar should contain. The first, and by far the most important, is clean water. You can substantially reduce the performance of a foliar application by not having clean water. And I'll speak in a moment about what defines clean water. Secondly, it should always contain a spreader sticker or a surfactant to make sure that we have good adherence to the leaf surface. They should contain plant nutrients and nutrition in the form of, I'm referring specifically to mineral elements such as calcium, magnesium, potassium, whatever the crop might require as indicated by a sap analysis or as indicated by our knowledge of that plant's specific growth stage and physiological processes. Optimally, it should also contain biostimulants. These can be hormone applications such as gibberellic acid, abscisic acid, cytokinins, naturally occurring products such as seaweed, etc. There's getting to be quite a broad array of biostimulants that are available in the marketplace today compared to what there were just a few short years ago. And then I would add microbial biostimulants such as fulvic acids, humic substances, and again, seaweeds. And there's other enzyme products, for example, that can serve to stimulate microbial populations. And just as a point of clarification, in this particular context, when I'm using the word microbial biostimulant, I'm referring to a material which can stimulate native or applied microbial populations, but isn't actually an inoculant. And that is another level where we can actually apply microbial inoculants into the spray tank, such as Micro 5000, or there's quite a broad array of microbial inoculants that are available in the marketplace today. So this is what we refer to as a synergistic stack, a stack of a product combination of all these different categories. And when we have the combinations, almost invariably, we produce a much greater response than we do when we apply just one or two of these on its own. We should also think a little bit about the mixing sequence, because if we produce tank mixes in the wrong sequence, then we can really suppress the activity and the response from biostimulants and microbials. So the correct tank mixing sequence is, first, we begin with clean water. It's the first thing in the tank, and we want to have the tank mostly filled. The reason we want to have first clean water and then second pesticides. So if we are applying any synthetic pesticides or even some biocontrol products, those should be the second material in the tank. And we want to have our tank mostly full of water, 80 to 90% of the water solution in at this point before we then continue to add other nutrients or other products. And the reason for this is because we want to dilute the pesticides, whether those be fungicides, insecticides, whatever the case might be. We want to dilute those pesticides as much as possible before we add any microbials or biostimulants. Because let's say if we do in reverse, if we first add clean water and then we add the microbial inoculants, the biostimulants, etc., when we put in pesticides last, those pesticides hit the tank in a very concentrated form. And of course, they do dilute out fairly quickly, but in the short amount of time that they are concentrated, even if it only lasts for a few seconds, they can have a very detrimental impact on the microbial population that is in the tank. So it's much better to add them first and dilute them with as much water as possible. And then after that, we now add any fertilizers and plant nutrients. Then we add plant biostimulants such as seaweed and hormones and enzymes, etc. Then the microbial biostimulants, and lastly, the microbial inoculants, so that we have done everything possible to buffer out any potential downsides from the pesticides before we add the microbial inoculant. And last of all, we add the spreader stickers and the surfactants. The reason we don't add the spreader stickers and the surfactants at the beginning is because, again, these surfactants can interact differently with some products when they are being added in a very concentrated form. So if you're adding pesticides that are still very concentrated or nutrients that are very concentrated, as they interact with that surfactant in the tank mix, they can actually change its effectiveness. So it's best to add those materials very last. So when we think about clean water, what is clean water? Well, let me just say this. Clean water is rare. Clean water, for the purposes of foliar applications, is defined as water that contains less than 70 parts per million or 5 grains of total hardness. So 70 parts per million or 5 grains of total hardness. And we use total hardness because it's an easy measurement. Many laboratories measure it. Lots of people have the information available. What creates hard water is primarily calcium and magnesium carbonates and bicarbonates. The most common challenge is with calcium bicarbonates. And the bicarbonates and the carbonates are the primary concern because these are two very reactive anions that love to bond with whatever is added into the spray tank. And when they bond with it, and they essentially bind it and greatly reduce, or in many cases, completely stop the plant absorption of those nutrients or those products that are being applied. And in fact, they are so effective at binding nutrients and enzymes and all types of different materials that can be added to a spray solution that when water has greater than 150 parts per million or 10 grains, not grams, but 10 grains of total hardness, it can reduce the product performance by as much as 70%. And that is true of any product. That's true of pesticides, fungicides, insecticides, herbicides. It is true of fertilizers. It's true of biostimulants, and it's true of microbial inoculants. So if you're putting on foliar applications with hard water, and by the way, 150 parts per million is not very much. Most growers in the country, greater than 80%, have well water with greater than 150 parts per million of hardness. So you're reducing the effectiveness of whatever product you're putting into the spray tank by as much as 70%. And this is very well known by many product manufacturers, particularly insecticide, fungicide, herbicide. Label rates are often variable and generally often applied towards the upper end of that variable rate to account for the loss of performance from water quality. This is the single number one biggest limiting factor for the effectiveness of most foliar applications. We've found that in many cases when growers report that they are not having the product effectiveness that they would expect or that they're observing on other neighboring farms, it's because of water quality. It's the number one problem that we have to fix. So how can we make sure that we have clean water? Well, the first step is get your water tested. Whatever water source you're using now, whether it's well water, river, stream, pond water, whatever the case might be, get it tested. Send it to a laboratory. Think of the dollar value that you may potentially be losing from your total fertilizer budget and pesticide budget if you're actually losing as much as 70% of your total product application. So potential clean water sources are rainwater or reverse osmosis water or water that has been tested to be clean. So if you actually have a laboratory analysis that shows that your water is clean from your well or from whatever source you're using, you can use that very safely. Rainwater is an option for some growers, not for all. And then that brings us to the third option, which is reverse osmosis. I can't even begin to recall how many times we have worked with growers who installed reverse osmosis systems purely for the purpose of producing clean water for their foliar applications. And small units have a price tag of about $4,000 to $5,000 and then upwards from there. But using reverse osmosis water, it's not uncommon. In fact, I would say it's very common for growers to switch to begin using reverse osmosis water and cut product application rates in their foliars from 30 to 50% and produce an equal or greater crop response than they have in the past. It's a very common response. So that can mean a substantial savings from product application costs. And much of this conversation, we've been talking about and thinking about nutrient applications and biostimulants, et cetera. But this is also equally true of herbicides and insecticides and fungicides. Think about the impact that you would have if you could cut your herbicide application rates by 30% or by 50%. And there's even a few growers who've done it by also working with structured water, using reverse osmosis and then structuring that water, who have reduced application rates by as much as 70%. So those are the effective clean water sources that you can use to really change the performance of what's happening in the field. Water sources that don't work and that are not appropriate. First on the list is softened water. And I put this list on here because I tell people that these are your three options. These are the only three options that work. And then I often get questions, well, what about this and what about that? And so I wanted to answer those questions proactively. These are the water sources that are not appropriate. First is softened water. All the water softener manufacturers that I've ever spoken with say that the sodium and the chloride do not leave the system and they're not in the water, they're not a problem. Well, the plants relate a different story. Whenever we put on a foliar application with water that has come through a water softener, the sodium levels and the chloride levels spike through the roof, which is not a cool idea. Using water that has been filtered is generally not enough because most filtration systems do not actually remove the water hardness component. They don't remove the carbonates and the bicarbonates. Using pond or stream water, unless it's been tested, if you have pond or stream water, and of course, I know that stream water changes seasonally. It's not always consistent. You may want to test it multiple times throughout the growing season. But our inclination is to think that, well, pond and stream water comes from rainwater. Rainwater is okay. Therefore, pond or stream water should also be okay, right? Well, it's usually not. And not always. There are cases where it is okay. If it's coming from snowmelt or something like that, it's usually fine. But it is also very common for water to, as it moves through the ground and through bedrock and then emerges in springs and comes into streams, etc., it's not uncommon for that water to pick up a lot of carbonates and bicarbonates from the rock that it has filtered through as well. City water should be an obvious no-no because of the chlorines, the chloramines, and whatever various compounds it contains as antimicrobials. And then lastly, it is not enough to acidify the water with added acids, such as sulfuric acid or phosphoric acid or acetic acid, etc. While those materials do help, they do have an impact, but they don't make nearly as big of an impact as reverse osmosis, and they just take the edge off the most severe part of the problem. So and here's why. Let's say that for the sake of discussion, we have a water source that has been tested as having 500 parts per million of total hardness. And that 500 parts per million, so we put into the spray tank, we put in enough phosphoric acid to drop the spray tank pH from 7.4 down to 5.5. We don't want to go too much more acidic than a pH of 5.5 because of optimal nutrient absorption, etc., unless we're dealing with an herbicide or something like that, but usually not. So we don't want to add more acids. But the phosphoric acid or sulfuric acid or whatever material has been added, when the pH is dropped to 5.5, it will only have neutralized perhaps 30 to 40% of the carbonates and the bicarbonates that are in the solution. And there's precise math for this. This can be calculated very accurately. So what happens is you put in an acid and the pH in the tank drops. But then if you were to leave that for a period of about 24 hours, you'll come back in 24 hours and you'll notice the pH has gradually come back up again, and it's right back up to a 6.8 or a 7, because some of those bicarbonates that weren't neutralized by the acids are now releasing and expressing themselves, and the bicarbonates have begun to bind and react with much of the acids that were there and neutralize it, and now the pH begins creeping back up again, which also means that you now have more available bicarbonates in the system. All of this is to say that that exact same reaction and sequence will also occur in a droplet on the leaf surface, and you will not get the product performance in a foliar application when you simply acidify the water in the spray tank. It can help, but it's not enough. It's not enough by itself. Another important aspect when we think about designing and developing foliars is using what we term synergistic stacks, combinations of products and product types to produce an increasingly greater response. So I haven't included any pesticides in this conversation because I want to emphasize the various synergistic aspects of plant nutrients and different compounds. So we begin the baseline that is very common for growers to apply as often plant nutrition, put it on fertilizers such as Triple 20 or Hypercap or Holocal, products that are supplying mineral nutrients to the plant. Then it's not uncommon for growers to add plant biostimulants such as plant hormones or naturally occurring hormonal products such as seaweed, etc., and add those on top of the plant nutrition. I put together this synergistic stack. Then we add on top of that microbial biostimulants, fungal inoculants, bacterial inoculants, etc. There's a sequence to putting together synergistic stacks. Biostimulants, plant biostimulants, and microbial biostimulants, etc., will always perform much better when plants have the foundational nutritional requirements that they need. So if you have a foliar application, and I'm just making up another hypothetical example, but let's say that we have low levels of magnesium and manganese in a given crop, and we also want to put on a seaweed application. So now we have a couple of possibilities. One is if we put on just the seaweed by itself, or we put on the magnesium and the manganese by itself, or third, we apply both the magnesium and the manganese and the seaweed in combination. The combination will outperform either of those two by itself. But if you put just the two individually, the magnesium and the manganese will usually outperform the seaweed, because the seaweed performs best, and I'm just using seaweed as a plant biostimulant as an example. The seaweed will perform best when the plants already have the magnesium and manganese that they need. So this is an important aspect of putting together these synergistic stacks. There is a sequence to flow through that if we use the right sequence, we're going to get a much greater crop response. So I wanted to describe some of the aspects and the characteristics of foliar solutions that we should be thinking about and that it may actually be worthwhile to measure in the spray tank. The first is pH. The ideal pH for optimal absorption of the nutrients on the leaf surface ranges from 5.2 to 6.4. You can go slightly above that, up to 6.8, but this is the kind of the optimal range where they are absorbed the most rapidly through the leaf and into the plant. And all of the advancing eco-agriculture products, nutritional products, are formulated and designed such that when they are added to a spray tank, they actually have a slightly acidifying effect, and they will generally naturally bring the pH into this range all on their own without the need to add any additional acidification products or any additional acids. The second characteristic that we should think about, and no, this is not cannabis. These are actually papaya plants, in case you're wondering. The second characteristic we should consider is EC, electrical conductivity. So there are two different frameworks for thinking about electrical conductivity. If we are doing consistent, repeated foliar applications on tree fruit or nuts or vegetable crops every 10 to 14 days, or perhaps as little as every 5 to 7 days in periods of peak disease and insect susceptibility, then the optimal EC range is below 3,800. Or there are two different metrics for measuring EC, and one is 1,000 times greater than the other. So the metric could be 3.8. So we want it to be below 3.8 or below 3,800. And otherwise, we end up with the possibility of over time applying too high, developing too high an electrical conductivity on the leaf surface, and particularly if we're doing tight applications, and having a detrimental effect on the plant instead of a positive effect. However, if we're applying foliar applications in a broad window of time, if we're growing broadacre crops such as cotton or wheat or corn or soybeans, we're only applying 2 or 3 or 4 foliars through the course of the growing season, then the electrical conductivity range is not as much of a concern. And I'm hard pressed to quantify exactly what the peak allowable limit would be, because we have worked with growers, many growers, who fly on foliar applications where the foliar application is 50% product and 50% water. So that is likely to have a very high EC, as much as 6,000 to 8,000. And we don't see any negative effects from that. And then, of course, the other consideration there is we have very small droplets and a very good distribution as well. So that may also have an impact. This is not something that we understand as well as I would like to at this point. We have observed that it is not a problem and that we get a very nice crop response from it. And that's something I think we need to continue to study and try to understand better in the future. Then there is a third characteristic, one that is generally never thought about or discussed and described in much of production agriculture. And this is a metric and a point that is described as the point of deliquescence. So what is the point of deliquescence? Describing that could be, and in the future likely will be, a short video of its own. But the point of deliquescence is the humidity point in the atmosphere at which a droplet on the leaf surface will dry out or remain liquid. It defines that threshold, that tipping point. So when I remember one of the materials that we used to play with to try to dry out environments in very humid buildings and humid environments and basements, etc., was calcium chloride. It's a very common trick to take a bag of calcium chloride and hang it above a drain hole. Calcium chloride is very hygroscopic. It pulls water to itself from the atmosphere, and then it drops it down. It would drop it right into the drain. So materials such as calcium chloride are very hygroscopic, and when they are contained within the spray solution, we would say that the spray solution now has a very high point of deliquescence. In other words, it will remain liquid for a very long period on the leaf surface, even in a low humidity environment. Because what happens is, as this small droplet on the leaf surface begins drying out, once it reaches a certain threshold, then the high point of deliquescence materials will continue to absorb water and pull water in from the humidity in the atmosphere, and they keep the droplet liquid on the leaf surface for a much longer period of time, which is, of course, going to tremendously increase the plant's absorption. And just a sidebar comment on plant absorption of nutrients, it's become obvious to me as I've studied this closely over time that we need to begin thinking differently about plant absorption of nutrients through the leaf surface. We know that there is some limited absorption through the stomata. We know that there is some diffusion through cell membranes. And I also have become convinced by the data that we've observed in the field, sap analysis data, etc., that we are perhaps undervaluing we don't understand well enough the impact that the microbial population can have on the leaf surface. When we have a very active microbial population on the leaf surface, particularly when we have a spray droplet that remains liquid, they can metabolize the nutrients that are contained within that spray droplet and allow them to be absorbed by the plants even faster. So that's something that I think we need to think more about in the future as well. Getting back to point of deliquescence, we want to include small amounts of a material that has a high point of deliquescence, such as C crop, magnesium chloride, potassium nitrate, calcium nitrate, etc. And again, in our product formulations at Advancing Eco Agriculture, we make certain that all of our formulations contain a small amount of some of these materials to make sure that the foliar applications remain liquid on the leaf surface for a very long period of time. When we think about timing, optimal timing for foliar applications is in the evening or early morning. Early morning produces the greatest immediate crop response, but is challenging for many growers to apply. So many also apply in the evening. Do not apply, obviously, during rainfall. While there is heavy dew, because when you have very heavy dew on the plants or a lot of water droplets on the plants, this depends on the type of spraying that you're doing. If you're flying on 4 gallons an acre with an airplane, then dew is not really a consideration. If you're putting on greater than 15 gallons per acre, then the foliar application can actually disturb the dew and have the dew drop off the plant and take the foliar material with it. So you actually get a much smaller quantity of applied product than you might otherwise expect. And when leaf surface temperatures exceed 78 degrees Fahrenheit. Now, just to reiterate, this is specifically leaf surface temperature, not air temperature. So when leaf surface temperatures exceed 78 degrees Fahrenheit, the plants will largely have slowed down photosynthesis and switched to photorespiration, and you do not have good nutrient absorption through the leaf surface at those higher pHs. So this is a diagram that I put together to describe the effectiveness of foliar applications in healthy versus unhealthy systems. So there aren't really any numbers on this graph, and I want to just describe this as a concept. So this lighter green, this pale line, is the line that is describing plant performance. And think of this line as representing a plant's photosynthetic potential, where on the lower left, we have plants' photosynthetic potential maybe at 5 to 10%. So these would be plants that have a lot of drought stress or nutrient stress. Perhaps they have nutrient deprivation of nitrogen or phosphorus or something like that. So these are plants that are not performing well at all. And then you come up to the second line or the third line, the point where the blue and the green line intersect. And these are going to be plants that are somewhere in the neighborhood of about 15 to 20% photosynthetic performance. So this is what is common and mainstream. And then that line begins curving upwards towards the right of the chart, and it ends with a crop that might be as high as 40% photosynthetic efficiency. And now let's look at the blue line. And what I want to describe is how foliar applications, this is specifically to foliars, the same general rule also holds true for other product applications, but foliar in particular, how these the crop response that foliar applications produce at these different stages. So at the first stage, all the way to the left of the chart, when you have plants that are really stressed from nutrient deprivation or water deprivation, putting on a foliar application at that point produces a tremendous response. You get a big bang. And so we have the blue line at the top of the chart. Then, over time, as the plants become healthier and they go up to 20% photosynthetic efficiency, you get this dip where now foliar applications are no longer quite as effective, and they don't produce the big bang response that they did when really stressed plants were present. So this is where described at the very beginning. If you have a plant that has a baseline Brix reading of 3 or 4 or 5, and you put on a foliar application, but the overall soil and plant ecosystem is unhealthy, you can get a Brix level spike from a 3 to a 12, but it drops back down again very quickly. It might drop down in a period of 4 to 7 days. So now you've produced less of a crop response. But then over time, as the crop health improves and soil health improves, that begins changing. And towards the back end of the cycle, as plant health improves, the response from the foliar applications also goes up dramatically, where you can put on fewer applications with less product contained in each application and actually produce a much bigger plant. Or you come back to where you produce this wow response. You put on a foliar application and there's this incredible plant energy and quality response you can actually see visually, similar to what you can see at the beginning of this curve when you have really stressed plants. So if you look at the summary of these points on the bottom, when you have unhealthy plants that are really stressed, you get strong product performance, but it requires more product application, and the response is fairly short-lived, and it's going to require more frequent repeat applications. But then the healthier the plants become, you get much better product performance, you need less product in the spray tank, and the response is sustained for a much longer period of time, and you actually need fewer applications over time. And then I want to reiterate this one point. I made it a few slides ago, but it's worth repeating. Biostimulants, whether we're talking about enzymes or seaweed products or essential fatty acids, or even perhaps microbial inoculants, plant hormone applications, etc., they will perform best when plants are supported with the proper nutrition. And we could even go so far to say as that when plants have the ideal nutrition, the optimal nutrition, the performance of biostimulant applications can tend to begin moving down a little bit because, and particularly it depends on, I should clarify that thought. plants make their own hormones. So let's make this conversation specific to hormones. Plants synthesize their own hormones, and their hormone synthesis is based on having the needed enzyme cofactors, which are your minerals and trace mineral keys, such as nickel and molybdenum and selenium and silicon and cobalt, etc. So when we provide all of the trace mineral nutrition, we are likely to, the plant will begin synthesizing its own hormones at optimal levels, and you may actually require less and get less of a response from synthesized plant hormones because the plants are much more vibrant already to begin with. I'd like to say thank you for all of you for attending this webinar so far. I'd also like to invite you to learn more about the information that we've been putting together and the courses that we've been putting together for the Regen Ag Academy. This has been a project that's sponsored by Advancing Eco Agriculture, where we've realized that we have learned so much valuable information over the decade that we've been doing consulting work and developing plant nutrition products, that we want to share this information and make it widely available. And many times the information is deep enough that we actually need to go deeper than we can on a webinar or in a podcast. So we have 2 courses that have been posted already, and we are working on more that will be released in the future. We have had some very powerful feedback on these various courses, and I'd invite you to, you can find them online. The URL is academy.regen.ag, and would love to see you there.